What if the most advanced technology on Earth isn't found in a laboratory, but buried under centuries of dust? We often view history as a linear climb from primitive tools to digital intelligence, but scattered across the globe are artifacts that defy this logic. From metals that shouldn't exist to astronomical computers built over 2,000 years ago, these impossible objects suggest that our ancestors possessed scientific secrets we are only just beginning to decode. Today, we are investigating the ancient technologies that, despite our modern supercomputers and precision engineering, we still cannot perfectly replicate. The story of lost genius begins with a substance so legendary it became the hallmark of the finest blades in history: Damascus steel. Between the 3rd and 17th centuries, blacksmiths in the Middle East produced swords with a distinct, flowing water pattern on their surface. These weren't just decorative. Records suggest they were incredibly flexible, yet hard enough to cut through other iron weapons without shattering. The secret supposedly lay in the Wootz steel ingots imported from India, but by the mid-1700s, the technique for making these blades vanished. When modern researchers analyzed original Damascus blades under electron microscopes, they found something shocking: carbon nanotubes and nanowires. This is a level of nanotechnology we only rediscovered in the late 20th century. While we can create blades that look like Damascus today through pattern welding, we have yet to fully recreate the exact chemical process and molecular structure that gave the original blades their near-mythical properties. How did ancient smiths achieve this without modern chemistry? This leads us to a mystery of a different kind, one involving light rather than fire. In the British Museum sits the Lycurgus Cup, a 4th-century Roman glass chalice that appears green when lit from the front but glows a vibrant ruby red when lit from behind. For centuries, this was dismissed as a beautiful accident. However, in 1990, scientists discovered that the glass was impregnated with particles of silver and gold ground down to about 50 nanometers in size. To put that in perspective, that is less than 1,000th the size of a grain of table salt. This is dichroic glass, a technology so precise that NASA later used a similar process for laboratory equipment. The Romans managed to hit the exact ratio of precious metals required to create this optical effect, a feat that requires a level of precision we associate with high-end clean rooms, not ancient workshops. Was this a localized miracle, or is there a chapter of Roman chemistry we've completely lost? If you find it hard to believe the ancients were masters of the microscopic, consider what they were doing with massive engineering. In the heart of the Andes, the Inca civilization constructed walls like those at Sacsayhuaman. These aren't just piles of rocks. They are composed of massive limestone blocks, some weighing over 100 tons, carved into complex, interlocking polygonal shapes. They fit together so perfectly that you cannot slide a single sheet of paper between them. Most notably, they used no mortar. During earthquakes, these stones are said to dance. They shift slightly and then fall back into their original perfect positions, while modern colonial buildings nearby often crumble. We struggle to replicate this today because the sheer labor and geometric precision required to dry-fit 100-ton irregular stones would be cost-prohibitive even with modern cranes. Before we move to the most complex machine ever found from the ancient world, think about the level of patience required for the Etruscan golden granulation. Between the 8th and 3rd centuries BC, Etruscan goldsmiths created jewelry decorated with thousands of tiny gold spheres, each no larger than a grain of sand. These spheres were attached to the base gold without any visible solder or seams. If you use modern soldering, the heat usually melts the tiny beads or leaves a messy residue. The Etruscans used a process called colloidal soldering, involving copper salts and precise temperature control that caused the metals to bond at the molecular level. It took modern jewelers centuries to even begin to understand how they achieved such microscopic perfection without the aid of magnifying lenses or electric furnaces. If you're enjoying this deep dive into the brilliance of the past, consider subscribing so you don't miss our next investigation into the shadows of history. While jewelry shows us their patience, the Antikythera Mechanism shows us their mind. Recovered from a shipwreck off the coast of Greece in 1901, this lump of corroded bronze sat in a museum for decades before X-ray imaging revealed its true nature. It is an analog computer from roughly 150 BC, containing over 30 intricate bronze gears. It was designed to track the cycles of the solar system, predict lunar and solar eclipses with staggering accuracy, and even track the 4-year cycle of the ancient Olympic Games. The level of mechanical engineering in this device wouldn't be seen again in Europe for another 1,500 years, until the invention of the first mechanical clocks. It uses a differential gear system, a concept we previously thought was invented in the 16th century. The Antikythera Mechanism proves that the Greeks had a mathematical understanding of the cosmos and a mechanical ability to manifest that math that was far ahead of anything we gave them credit for. Then there is the mystery of the Greek fire. Used by the Byzantine Empire to defend Constantinople, this liquid weapon could be sprayed from tubes onto enemy ships. Most terrifyingly, it allegedly continued to burn on top of the water, and some accounts claim that water actually accelerated the flames. The formula was a state secret, known only to the emperors and a few select families. When the empire fell, the secret died with it. While modern napalm or white phosphorus has similar effects, we still don't know the exact organic composition of the original Greek fire. It was a chemical deterrent that changed the course of history for centuries, yet it remains one of the most guarded secrets of the Middle Ages. These artifacts and techniques represent more than just cool gadgets. They represent a fundamental challenge to how we perceive human progress. We like to think of history as a steady climb upward, but these technologies suggest that the path of human knowledge is actually a series of peaks and valleys. Entire systems of chemistry, physics, and engineering have been built, perfected, and then completely forgotten, leaving us to rediscover them centuries later. As we look at the precision of the Antikythera Mechanism, or the molecular bonding of the Lycurgus Cup, we have to ask, what else have we forgotten? If a civilization can master nanotechnology or complex mechanical computing, and then lose that knowledge for 2 millennia, what does that say about the stability of our own technological era? We are currently building our world on digital foundations that are incredibly fragile. If the power went out tomorrow, how many of our miracles would be understood by someone digging them up in the year 4000? The mystery of these ancient technologies reminds us that primitive is a word we use only when we don't yet understand the genius of those who came before us. Every time we analyze a Damascus blade or an Inca wall, we find that our ancestors weren't just surviving. They were innovating in ways that we are still trying to catch up to. The question isn't just how they did it, but why they stopped, and if we are fated to follow the same path of forgetting. To see how these engineering marvels compare to the massive structures that still baffle modern geologists, click here to watch our investigation into the world's most mysterious megaliths.